Okay, I assume you've tried this on your own first. If not, go back and try it on your own. We want to graph k is greater than or equal to -5. So we've got to put something at -5. The first decision is, do we put a solid dot or an open circle? Since k could be exactly equal to -5, we should put a solid dot. K is greater than or equal to, so k could be -5 exactly. It could also be any values greater than -5, so the arrow should go to the right to indicate that the solution set includes all the values greater than -5 as well as -5 itself. That's how you graph an inequality like that. Now the solution set means what are all the possible values of k. You start with the least possible value, which in this case is -5. Then you put a comma and you go all the way up to the greatest possible value. Well, what is the greatest possible value? That arrow goes to the right forever. So where does it end? It never ends. Positive infinity is where it ends, or doesn't end. But you indicate that the greatest possible value is positive infinity. Now, here's where the notation gets a little tricky. Brackets mean the value is included. Just like the solid dot means the value is included. Included. So I'm going to put a bracket around the -5 because the value of k could be -5. If I meant it starts at -5 but doesn't include -5, that's when I would use parentheses. And here's where this idea of bracket or interval notation gets even trickier. While infinity is part of the solution set, we never put a bracket for infinity because nobody knows what infinity is. You have to put parentheses for infinity because it's an imagined value. It's not something you can pin down. And so infinity always gets parentheses. But just focus on the non-infinite value and decide whether it should be a bracket or parentheses. In this case, a bracket because it is included. Write, then graph an inequality to represent this situation. Joseph decides not to spend more than $4 at the store. Well, if he decides not to spend more than $4, it would be okay if he spent $4. Or he could spend $3, $2, $1, $0. It seems like he could spend x could be less than or equal to 4. It would be okay for him to spend 4 because spending 4 is not spending more than 4 or any value less than 4. Now, when you start doing word problems, it gets a little dicey, and so I'm sure some of you are already wondering about something. I'll get to that in a minute. But let's just graph this inequality and forget about the context of the situation just for a second. But trust me, I'll address what you're probably thinking about. Could he spend exactly $4? Yes. So I put a solid dot at 4. And then he could spend less than, so I'm going to put the arrow going to the left. Now, students will always say, and they're right, he can't spend negative money. I mean, unless the storekeeper was just very generous and wanted to give him money for walking in the store. But that's unreasonable, and so really this is something called a compound inequality, where he could spend less than or equal to 4 or greater than or equal to 0. But trust me when I tell you, for now, let's just leave this part off. We're definitely going to get to this part in advanced math, but let's just ignore that and just say it could be any value less than or equal to positive 4. So think about what the interval would be. The least possible value, according to this graph, again, and not taking into account that you can't spend negative money. This arrow ends where? Not infinity, but negative infinity. And so the least possible value is negative infinity. And while that is included in the solution set, like we said, infinity and negative infinity always gets parentheses, which I should be careful to draw better than that. Okay, the greatest possible value is 4. Now, should 4 be included? Should I use brackets or parentheses here? I should use brackets because 4 is included in the solution set. The amount that he spends could be exactly equal to 4. And so this is the graph. This is the graph. This is called interval notation. And this is the inequality. You should label those because I'm going to ask you for one or the other or multiple of those, and you need to know what I'm referring to. Both the graph and the interval notation describe in different ways all possible values of x, or what's called the solution set. Which one does it graphically?